Well, good afternoon, everybody. Welcome to our HILT CRC webinar for this week. My name's Peter Ashman. I am the Cross-Cutting Technologies Research Program Lead for the HILT CRC, also our Deputy Research Director, and I'll be hosting you for today. As you can see on your screen, our title of our webinar today is Accelerating Decarbonisation Through Industry Hubs, European Lessons and Their Relevance to Australia's Industrial Regions. I wanted to start by making an acknowledgement to country and to acknowledge the traditional owners of the land. I'm coming to you today from Göran land in the Adelaide Plains, and I wanted to offer my respect to the Göran people, acknowledge that the Göran people as the custodians of the Adelaide region and that their cultural and heritage beliefs are still as important to the living Göran people today. Our speaker today is Professor Göran Roos. Göran may be well known to some of you, but maybe not to everyone. There's an extensive CV on the screen before you. I'm not going to go through that line by line. Göran has had a long association with Adelaide and South Australia and the University of Adelaide. He has an adjunct position with the Institute for Sustainability, Energy and Resources at the University of Adelaide and many other adjunct roles in South Australia and across the world. He's based in the UK, so he tells me, and he's been in Adelaide now for a couple of weeks, very busy and about to head home, so it's great that we've been able to hear from him today. The agenda is a very simple one. We're going to hear from Professor Roos for about 30 to 40 minutes, and then we'll have some time for Q&A at the end. So please feel free to pop your questions in the chat as we go, or the Q&A, and we'll get to those at the end. So I'm going to hand over to Göran now. I'm going to stop sharing my screen and he will share his. Thanks, Göran.
Thank you very much. I'll see if I can get this to be operational as always. There we go. And we'll do that on there. See, is that visible to you now?
Yes, it is. Thanks, Göran. All clear.
Thank you. All right, thank you. So I will run through a few comments on the topic that we have discussed, that I was supposed to discuss. What I want to say first, though, is that don't worry about taking screenshot or pictures. You are welcome to the slides, primarily because on some of them there is quite a lot of information which I will not go through, but you can look if you're interested afterwards in peace and quiet. So I'm going to talk a little bit about what we have learned in Europe on these things. And of course, there is these dual challenges about doing industrial decarbonization. It's partly about the climate imperative and partly about the economic realities. And I think that the questions around the economic realities have become more and more clear to the decision makers. They probably have been reasonably clear to industry, although not completely, but they become clearer to the political decision makers as things has moved forward. So this is basically not that easy, as you probably know. So what it means, if you're going to be successful, you have to make some pretty transformative changes to all the production processes. And in these sectors, the highly energy intensive sectors, these production processes have been quite unchanged for quite a long time. So finding new ways of doing things has been occasionally a bit challenging. The other word that appears in the title here is hubs. And what I want to just do a little bit here is say a few words about language precision, because when we talk about it, we normally talk about agglomerations of different types, and there are actually 4 types. And occasionally we throw around words like hubs when we don't mean hubs, but I just put them up here so you can look at them. So basically you've got hubs, you've got clusters, you've got industrial districts, and you've got regional or local innovation systems. And they are actually quite fundamentally different that you will see on some of the slides at the end in terms of how they work, what they require to work well, and who the key stakeholders are that need to make decisions. But there are, of course, as we know, quite a lot of benefits associated with different type of agglomerations, which is why they either emerge or are created and remain. So if you look a little bit about Europe's situation, we have these four basic sectors, which are cement, aluminium, steel, and chemicals. And of course, steel is the big one in terms of emissions. It's about 25%, so about a quarter of EU's industrial emissions. And that is in spite of 56% of it coming from recycled scrap. So it is the first sector they're really trying to move through with hydrogen, and I'll say a little bit later on challenges around that. But that is the big sector. Then we have cement, which is a big production center. Of course, it's infrastructure and all that stuff. It makes up about 22% of the emissions. You see, you add those two up straight away, you've got almost half. Chemicals, which is struggling in Europe at the moment. I'll come back to that. And then we have aluminium. And then, of course, there is general activities that these are trying to do. There's something about industrial symbiosis. There's something about recoveries. There's something about tracking these things in a way that can be audited. So there are a few progress areas around that. I mean, material recovery in Europe is actually quite high. 80% of the steelmaking slag is repurposed, and the high-value scrap flows are generally tracked now at an increasing level with blockchain, so that you can actually claim that things are clear and you can support your claim. When you look at how these sectors are trying to decarbonize, there is basically 5 key pathways that you can do sequentially, parallel, or only one of them. One, of course, is increasing efficiency on the circularity, which is around, basically ensuring that you reuse what you have. And on the whole, we see that possibly can take care of about half of the industrial emission reductions that is aimed for by 2050. It is not that expensive in terms of capital investment, but it requires quite a lot of change in many of the companies' business model, which of course has internal consequences for these companies. We can move down the pathway of electrification and clean energy, which again is fine, but it requires A, that you have access to electricity, and B, that it is cheap. And that has not been the case in all areas of the EU, and some decisions made by some of the countries has not been conducive. So, for example, Germany's decision to leave nuclear behind has meant real problems for the German economy in terms of access to electricity that is cheap and guaranteed. At the moment, that means that Germany, because of their need and dependency of carbon-based fuels for electricity generation, is now the country that is stopping EU from reaching its carbon reduction objective. So we will see what happens with the new government. Germany is opened up to maybe reverse some of these decisions. Hydrogen-based is where we're going, but of course, there's a difference between can and being economically feasible. Back of envelope calculation, very quickly, removing things like capital cost and transportation cost means that at the present carbon price that you would have to pay for your embodied emission of about 80 euros per ton of per ton of CO2. And if you have an average embodiment in steel of about 1.85 tons of CO2 in a ton of steel, that means that the hydrogen price would have to reach something in the vicinity of 2.3 euros per kilo in order to make that a viable way forward. And we all know that is far from what the price is at the moment, which is one of the reasons, there's another reason as well, why some of the steel producers have delayed some of the move into the hydrogen-based steel making DRI route, basically. The other reason is that there is really no access to PEM-based electrolyzers at the scale needed for these things, which means that the companies who want these are a bit worried that the quotes they might get are not going to be lived up to reality. So in the trade-off between first mover advantage and first mover disadvantage, at the moment, the disadvantage relating to the combination of these two things means not that they have stopped their move towards hydro-based steel making, but instead that they are delaying some of the steps in the pathway. The next step, of course, is carbon capture. Cement calcination is one of those areas. It's one of the things you can do. The challenge, of course, is that it's very difficult to reuse the CO2 in any commercial way, given the lack of cleanliness in the captured CO2 that you have and the cost associated with cleaning it up, which means, for example, it's difficult to use CO2 from cement facilities into food industry, which I'm sure some of you have been exposed to when you look at what happens when some of these power stations in Australia close down and the food industry then screams, where did our CO2 go? And finally, you can look at biomass and alternative steep flow pathways, and that's possible. The chemical sector is targeting kind of 25% replacement by 2050 in terms of its raw material, trying to get it bio-based rather than petroleum-based. The challenge with that is twofold. One is if you have the same molecule produced in a different way, it's normally more expensive. And that means that if you serve a commodity market, that is almost impossible unless you ask for subsidies. And as a government, you do not want to subsidize this, because then you're on the hook forever, because once you get subsidies, there is no incentive to change. The other thing is, if you get a different molecule which has the same functionality, you need to change your process. That means capital investments in order to offset the cost on that one. And the government could possibly subsidize that. The benefit is a one-off hit, but you then need to understand how the new process is going to look. And this is a bit of challenge. In addition to that, we have worries about the long-term availability of biomass, because there is a lot of demand for the biomass, and the demand is, looking forward, exceeding the supply of biomass quite substantially. So I spoke a lot about these things, but I mean, the key challenges for steel in Europe is this thing, balancing decarbonisation with competitiveness, making sure it's affordable energy, both for the electricity as well as for the transition technologies. And then the problem is also that this varies heavily between regions. And I'll show you some numbers a little bit further on. And we can see that some people are playing in that space. The first one is the HYBRIT project in northern Sweden, which actually has produced the first operational steel from, I think it was 2021, which has been out and evaluated by potential customers and approved, be that the Volvo trucks or wherever they were. So they are in process, as I said, probably, I'm not believing 2027, but maybe 2028. Stegra, which is the other one, basically across the river from HYBRIT, is again launching in 2025, and it's expecting to start to get things on track 2026, 2027, but are pushing the electrolyzer investment a little bit further in time, maybe 2028 for the reasons I stated. And then you have ArcelorMittal, which obviously is trying to do things, but you can see that they have also delayed, blaming policy uncertainty primarily around this, but it is clear that also the cost issues relating to hydrogen and other things play in here. Biomass, it's on track for a pilot plant, doing reasonably all right, but I mean, it doesn't save 100%, but it probably saves about, round about half of what you can do in CO2 per embodied ton. And then electrification with different areas around these for, which you can see in Austria. And then you have a little bit interesting technology people are looking into from Boston Metal, which is relatively early on the TRL yet, but it may have some opportunities moving forward. The policy framework here, of course, is that there are a set of action plans and there are some principled paths forward. What is worth noticing is there has been 33 near zero emission steel projects announced, but very few of them are on schedule, either because they haven't been able to maintain the schedule or because they have delayed the schedule. And there are some variations of regions, what I said, around these things. Cement, very similar around that. Carbon capture is the key. There is one plant that Heidelberg has in Norway, which is full scale. It's a really full-time first one with total CCUS in operations, and it captures about 400,000 tons of CO2 per year. So that is one plant to look at, but of course it wasn't cheap and it required a lot of support to get there. And then there are a set of alternative solutions, which are used basically worldwide to deal with this. Lots of investments are required. It's a lot of money to be put in to get this to work, and not all that money is available, and not all that money at the moment can be seen to be invested with a sufficiently high return to make it happen. Chemical industry, again, The challenge with chemical is that it is as an industry, it's important both in what it does, but also as an employer. You can see in Europe, it's about 1 million plus employees across the Europe for this industry. And it is a sector that does struggle a bit in Europe at the moment, and it has to do with the energy cost. And since a lot of this sector was located in Germany, they have been the primary victim of the German energy policy, which has not been industrially conducive. And that is part of the reason why they are, as you will find out, they are moving quite a lot of their production facilities overseas. I'm not going to talk too much about that. Aluminium, very similar story around that. You can look at the deals that's around that. Nothing complicated around that. There are some technology issues around that. Common success factors from the technology implementation across these things is that it requires cross-sectoral partnership that cuts across the whole value chain, from the user of the product to the originator of the raw material. It requires long-term contracts and offtake agreements providing market certainty. The reason why Stegra has managed to build, or are managing to build, the first green site iron or steel producing facility in Europe for 50 years is that they have managed to raise money for their investment and also secure that money against offtake agreements signed with major customers. So this was the fundamental requirement to make this thing take off. You also require flexible system design that can adapt to evolving condition, because of course technology changes, but also does policy and practical things like electricity prices. So for example, HYBRIT has just verified that they can store hydrogen underground in big caves to balance variations in the production driven by, for example, energy prices. There is the complementarity policy support requiring, which is not always there and maybe not always very cleverly integrated, but is there to some extent. And where it works, it is a success factor. There are some technology-specific learnings we can touch upon. Cost premium is high for hydrogen. Carbon capture requires, really complex, requires a lot of time, and it does drive up energy use. Electrification, grid connection, it's one thing generating electricity. Can you get it to you need it? Can you have the stability in the network where is the power cables there? And there is a bit of challenge around that. There's something about material efficiency, quality control system for high recycled content. Can you guarantee it is what it should be? And it requires digital tracking, which means you can, if you have that, apply it for some premium applications. And it does require certain business model innovations that we see coming across, and they have managed to be quite successful around some of those. I mentioned some of those things, the HYBRIT project, the Kalundborg symbiosis network, the hydrogen implementation by Metal, and then the HYBRIT plant in Norway. So there are some interesting success cases around this, but they did require basically good government support in both policy and money. So carbon pricing is really important about this. The higher the carbon price, of course, the more the change will be driven. There is a need for financial support and you probably need, in this case, you need some form of government money rather than market money, because the market money is really difficult to support these things with a high uncertainty and the doubtful profitability. There is a need for infrastructure development, everything from, cables for electricity to all the other things that you need. And you also need a just transition mechanism, because some of these changes require different skill in your workforce, and not all that workforce will be able to transition. So there is a requirement for skills development as well as dealing with the potential shift in the workforce. And if we look for these things, which I'm not going to go through, but I've made a set of tables here. We talk very much about the success factors for decarbonization and what the roles are and what the challenges, what the advantageous issue is, what the roles of the different players are, and the do and don'ts that we have from Europe in this first case about decarbonization, industrial hubs for decarbonization. And it's very important, I think, the right side column to look at what have we learned about what to do and what we learned about don't do. There are some issues around that. Then we have industrial clusters, a similar table put together. And again, what do we learn that works? What should we do? And what have we worked that you should avoid doing, right? We have looked a little bit about, you know, the industrial agglomeration generally about these things. Again, the do's and the don't around the industrial districts, the do's and the don'ts, and regional innovation systems and the do's and the don'ts. So I put these together so you can, in peace and quiet, reflect on these things, and do that in combination with the first slide where I defined what these things are, because you have to look in your area geographically. Are you actually talking about a hub? Whether you call it a hub, or you're talking about a cluster, or you're talking about the district? What are you talking about? Because they are quite different in what they do, although they are all different type of agglomerations. So spend some time on this in your privacy, I would say. Now, if I look at these and then say, okay, from a European perspective, and of course it's a bit high to say give advice, but what would be my recommendations for policymakers here generally? The first thing is you need an integrated policy framework that connects climate, energy, industry, and circular economy objectives. And anything you do that is stovepiped will not be very conducive for this. So the people who sit in the Department of Industry will have to talk to the people who are responsible for energy, who will talk to the people who are responsible for climate, to get an integrated policy framework. And you need it both federally and ideally also conducive on the state level if you can. This is not something that traditionally, in my experience, has been 100% efficient in being implemented in Australia. That is a really important recommendation. Then you have to deal this thing with permitting, you know, how to get these decarbonisation projects to be approved from a regulatory standpoint. So you need a kind of one-stop shop approval for that, and you should also aim for a assumption of approval. And what that means is that you should have a situation where you can define the required information that has to be put in by the applicant, make absolutely clear that is there with comments from all the stakeholders, and all the consultation needs to be done. Where all the information is there, then you should have a timeline based on experience, how long it will take the regulator or whoever it is that is responsible for the permitting to go through the process. And then you start the clock. And if the regulator or approver have not managed to finish their internal work in the set out time, then you have an automatic approval. That puts pressure on the regulator to adhere to these things, and it also puts pressure on the applicant to ensure that all information required is there. That would drive things very well. Then you have to review building codes and product standards to accommodate these low carbon materials. The challenge that frequently exists is in the building codes, but also around things like the way procurement operates. So there are ways to make, for example, roads using materials that make it cheaper to make the road than it does presently, and the material will also absorb carbon. So it's a new technology, it is low cost, and if you go and talk to senior executives, say wonderful, and then it ends up in the procurement, and procurement of course buys on two things. One is cost and the other one is risk. So getting them to buy something they have never bought before is extremely difficult, and that requires a change in how these type of procurement organizations are managed. So you need to both change the codes and the product standards, but also change the way procurement is managed, both in public and in private organization. And the larger they are, the more this change is required. And then you need to have some innovation zones for testing new industrial processes where there are some regulatory easements in order to allow you to test things that maybe do not adhere to regulations at the moment. But then you have enough information at that point to make a more general regulation when it's going to be put out there. So that's the first thing that needs to happen. Secondly, you need to provide some economic incentives. And the best one when it comes for decarbonisation is some contracts for difference. They have been seen to work quite well in specific domains. And if you get the pricing there, you can get some interesting market behavior that is conducive for this. You also need to create some form of targeted grant program for first of a kind implementation. In other words, the testing new area, because obviously some of these things are expensive. They may not on their own have a commercial payback, especially if you find out that it doesn't work for your area. And therefore you need to reduce the risk around these things. And part of that is a grant program. You have to develop some sustainable finance mechanism with the financial institutions, be they green bonds or whatever it may be. There means some structure for that needs to be put in place. And as I said, the procurement is critical. If you look at policies, you basically have two big policy levers. You have supply side and you have demand side. Supply side includes things like grants and tax credits and all this kind of stuff. When you provide a supply side policy, it drives activity. It does not drive outcome. You have to report on activity. You don't really have to report very much on outcome. When you have a demand side policy like procurement or regulation, it drives an outcome. And what you look is the outcome. So generally speaking, across the OECD world, demand side policies are substantially more successful in generating an outcome than supply side policies. And the most effective one is procurement. So in procurement, you only get paid if you deliver, and that drives change. So if you can change your public procurement and big corporate procurement to look at these type of solutions, then you will have a major change quite quickly. Then, of course, you need your infrastructure development. There's all this planning across electricity, hydrogen, CO2 and whatever it is, material flows. You need to figure out what infrastructure is needed for the logistic, what infrastructure is needed for distribution and energy, what infrastructure is needed for electrolyzers and all the associated areas. And it's a lot of planning because there's a lot of infrastructure to be put in place. And you then also have to prioritize this kind of no regrets hydrogen infrastructure, which can serve, huge users. You can have hydrogen that goes straight into ammonia that in turn can be used for anything from fuel for coastal vessels to fertilizer production, to explosive production. You can use it to methane. You can use all kinds of things, of which the hydrogen itself that might go into DRI or any other green metal activity is only one, and therefore you can play the balance between these two things depending on how the demand develops. But you then, of course, have to have a location and a cost level that makes it feasible to move through all those different alternative application pathways. Yeah, you need very advanced sorting and processing. I mean, one of the biggest opportunities in this space is generally the whole recycling. I mean, just think of the amount of solar panels sitting around, for example, in Victoria, huge amounts. Develop technologies that allow you to extract the critical materials out of those things, tellurium or whatever it is, the technology and process we do not have at the moment. That is critical. And also, as you will see in some of the previous slides, when you look at them, there are some very sophisticated processes with sophisticated technology to sort scrap that goes into maybe aluminium and so on. And then you need the infrastructure for that to enable the high quality aluminium to be produced based on high quality recycled input. And then, of course, you need to strengthen whatever form of industrial agglomeration you have because you have shared facilities. And as I said before, you need to map out the skill requirement and the training pathways for the industrial transformation this entails. You need to update your vocational curricula to incorporate whatever the principles are that is going to be put in place there. You have to establish industry learning centers with major industry facilities so that suppliers and the companies themselves can develop the capability and absorb it that is necessary to move into this area. And of course, you need then to also have a plan for those who are no longer going to potentially have a job in this domain. So for company, you need to do a bit of strategic planning around this decarbonization. You need to implement what you're doing to go. You have to work cross-sectorally to make this happen, and you will have to invest in technology. Of course, you have to be clever about it. There is no choice in many areas. And the C sectors, of course, as we said, this integrated approach is about technology innovation combined with circular economy, combined with policy support, combined with business model innovation. Nothing works well in isolation. It's all of them together that makes a difference, that makes it also commercially viable. And then you can go around how you work on the hubs. You can look at your alternative multiple pathways, and you can try to be a bit proactive about these things. So conclusions is we have experience in Europe. It means it is possible, but it is not easy. And agglomeration does accelerate transformations because you have collaboration and you have shared infrastructure. And in this case, for example, I just took South Australia as an example, but it has a lot of renewable resources, existing industry cluster and skilled workforce. But that may exist in many other places. But of course, they also has disadvantages. There are big, extensive distances. There is a lack of modern facilities. There are many areas. So no place is perfectly positioned for this. Some will have it a little bit easier. Some will have a little bit difficulty. But it is really addressing the uncertainties. So you need to form some form of task force with government, industry and research represented. You have to develop these agglomeration strategies with specific instruction and policy roadmaps that is appropriate to the location you're looking at. You have to have demonstration projects. You have to fulfill the Missouri School of Management show me principle, and you have to create workforce planning. And of course, workforce is one of the biggest challenges over at least the coming couple of years. And then you have to have a long-term vision, whatever it may be. Are we going to be world leading on these things? Are we going to integrate renewable? Are we going to have resilient industry? Can we have sustainable transformation? Are we going to have, what are we going to have? And you have then the great template around these things. So that was a very brief run through. And with that, I am very happy to take questions. And as I said, the slides will be available for those who choose to request them. Thank you very much.
That's great. Thanks, Göran. It's a whirlwind tour of how to decarbonise with some good lessons there from Europe. A reminder, love to take some questions in the chat. We've got one comment actually, Göran, not sure if you noticed it, from Johan Rinhofer, just an update on progress at Stegra, I think.
Yeah.
Not sure if you're aware, but according to Johan, they started to build their electrolyzers 3 weeks ago, so that sounds promising.
They have. That means they got the quote that we're waiting for. So that's it. They probably go down the modular route, would be my guess on that one. Yeah.
That's great. So I might kick off with a question of my own, and hope that we'll get some others through the chat here. Where shall I start? I'm interested in your thoughts on what's you mentioned how hard decarbonisation is at sort of global scale, and that's what's required for us to deliver what we need to deliver. Of course, there have been other instances through history where we've undertaken global action to deal with major crises, ozone depletion, lead in petrol. What are the sort of fundamental or key differences, do you think, between the current challenge and those ones that I think we were eventually able to manage successfully?
Yeah, I think there are a couple of things. One is the global context we sit in the moment. Just to take an example, so the Europe is at war, right? And that means, of course, and you combine that with the fact that the US is making noises about not necessarily supporting Europe, and that has forced not necessarily a bad change, but Europe needs to take bigger responsibilities. That has the immediate effect that government budgets are being used and redirected at things like defense spending. So you're going from, in some countries, 1 point something percent, and you're now going to aim at 3.5% and maybe even 5% of GDP on defense. That means, of course, that that there is very little money left over for other things, and that means budget reprioritizations, and that also means that potential money that might have been available for or thought to be available for this transformation may now not be available with that or pushed into the future. So that is one of the first reasons around this. So we live in a context where there is a multipolar world rather than a one single monopolar world, and that means that agreements are very difficult globally, and that priorities are on the security side at the moment rather than the green side, at least in the short term. So I think the multipolarity combined with this is a difference in area. The second one is that in ozone depletion, you had a fairly limited number of sectors that you dealt with, and there was nobody claimed that ozone was a good thing. In that sense, there was a general consensus that this is a challenge. We need to deal with it, and we have a limited number of impacted organizations, and we can structure ourselves policy-wise and support-wise to make this happen. That is not the case in the decarbonizations. We have everything from people who claim that it's not a problem to a multiple sectors impacted, and where the solution varies heavily between sectors, which means that policy environments and implementations are quite difficult. So those are just some of the areas. So the answer is we have historically managed to do that. We probably couldn't really easily do it, even if the security area was different. But if you add the security concern to this, you can see it's going to be really challenging.
Okay, that's interesting. Still waiting on questions in the chat. You mentioned one of the challenges then was the fact that we don't seem to have universal agreement that this is actually a problem that we need to address. And I mean, it sort of constantly amazes me that that's the case. And I mean, my view has always been that those people don't really believe that they're just using that as a way of positioning themselves against the in a political sense against an opposition party. But I mean, what's your view on that? I mean,
no, I think it's well, you're entering into a debate which is not in this area, but quite interesting. So you have, if you look at where the political landscape is moving in many countries, especially if I look in Europe, it is a gain for what people generally call the right-wing side of politics. And why do they gain? Well, they gain primarily because the people who vote for them feel neglected by the existing parties and policies. Many, not all of them who voted them, have generally speaking a below average level of education, which means I have no negative sense of it itself, but it means you have a lower ability to absorb information and make judgment of it and capture the finer distinctions. That means that you will also in the social media world end up in echo chambers where conspiracy theories and other things are embraced. And at the end of that, you will come out having faith. I use that in the broadest definition of the term. And when you have faith, you end up in a world where don't confuse me with facts. My mind is already made up. And if part of those made up views that says I am absolutely convinced is that A, there isn't a problem around this one, or whatever you try to tell me is going to be detrimental to me, therefore I am against it. And you can see that, there are, for many of these politicians, it doesn't really matter if it's a Nigel Farage or a Donald Trump or the new president in Poland, whatever it is. A large group of the people who are their electorates belong in this category where they have faith, which means that doesn't matter of the political individuals they vote for will fail or succeed. Any failure will be blamed on others, and any success will be credited to the individual. And in these environments, where you have a political environment like that, it's extremely difficult to make decisions based on science because you cannot convert people of that persuasion with factual arguments. That is not how it works. You have to use emotional arguments on the same level as the conspiracy theories that they embrace. Very long, very incomplete issue, but it does point at some of the challenges. And don't forget that 20% of voters in Germany voted for the extreme right-wing party that got a very strong showing and have majority in many of the former East German states in Germany.
Very interesting. And as you said, probably a little off topic, but yeah. Jordan's going to bring us back on topic. So Jordan's put a question in that. So he said, what about lessons learned from Asia? Is agglomeration equally important there, or are there different, or does their different governance system play a role?
Well, agglomeration are important everywhere. The ease of organizing them is different. So in countries where you have a high starting trust level, the benefits are much stronger. So agglomerations in Japan, for example, tend to have relatively strong and get off the ground quite quickly because you have a high trust level between individuals. In countries where you have a low trust level, it takes longer to build an agglomeration. So if you look, for example, at the carbon fiber cluster that you have in Geelong, you can ask the participants how long it took before they were able to get to a level of trust where they can talk to each other. So in Australia, and now I'm going to be extremely politically incorrect and basically put my foot in it. But if you go into a meeting between two individuals that for the first time are going to talk about something, the starting assumption is frequently win-lose. Right. So, I will win at the expense of yours. It's kind of zero-sum game view. Whereas if you have other cultures, you go in and you have a win-win assumption. We say, if we get this right, we will both come out better off. And of course, it is easier and quicker to get to an agglomeration benefit in a win-win assumption than it is in a win-lose assumption.
Good. Okay. Well, no more questions coming through on the chat. I was going to ask you, you mentioned CO2 capture in cement, and you mentioned, I think, was it Heidelberg Cement and their operations. I was going to ask about their CO2 reuse, but then I saw that you mentioned that they're looking at methanol. I'm just wondering, with CO2 reuse options like methanol, and other sorts of chemicals, do we have the right sort of systems in place currently to be able to track the ultimate sort of fate of that carbon? I'm thinking in terms of methanol that might end up being used as a fuel. How do we treat that carbon?
Yeah, well, you're into this, scope 1, scope 2, scope 3 type emission challenge. And that is a challenge, which is why the EU's implementation has initially focused on scope 1 and scope 2, because scope 3 is incredibly difficult. And we don't necessarily have all the tools to make that possible. You can make estimates, but that's all going to be challenged one way or the other. So the simple answer is we don't have the tools. We have to get a better understanding of it and find some commonality of how we capture the information that we need. And even, here it's probably in some of the domain, it's probably better to be approximately right than to be absolutely wrong. And that is a philosophy that you need to drive down in some of these areas.
Great. Okay. Now we've got a couple of questions coming through now. One from Ro Richardson says, I'm involved with Western Australia's Clean Energy Future Fund, targeting projects expected to get maximum decarbonisation directly or through wider adoption of supportive technologies. Can you suggest any focus areas or strategies?
Focus areas will have to be determined by you, because you are the area that knows your economy and what you're looking for. I think the strategies you're looking for is basically maximizing impact. And that means you need to look at sectors where whichever project you're supporting has a very high probability of succeeding and a very high probability of being rolled out across that sector. And a rollout would then have a major impact on the economy's CO2 emissions. Plus that it should also ensure that that sector of the economy preferably increases its competitiveness. And what that means is something that you will have to look at in your area, but it is thinking about this scaling up aspect of what you are supporting.
Thank you. And we have a question from Jenny Selway. What's the role of research in industrial hub development? Should studies be location specific while also aiming to inform general policy development? Or are there still general non-location specific research topics to be tackled?
Well, there is absolutely no location. There is absolutely many questions to be tackled that are not location specific. So, things like I said in the beginning of my first slide, that many of the processes that are used in these energy intensive industries, and even more so when we go down to the next level of industries, have been unchanged for quite some time. And that means that you need to dramatically change these processes and improve their performance in many dimensions. And some of that thing will require research around understanding how it works. I mean, a good example is the chemical industries. So if you come up with a molecule that has a functionality very similar, but the molecule is different, what are the implications of that in everything from what type of blending fission, what are the consequences of laminar flows? I mean, all this kind of stuff that needs to be understood, and that requires research on a level that has nothing to do with the location as such. So that's my first question, my first answer. Secondly, in many of these areas, you need both innovation and research, and frequently those two words are confused. In my simple life, research is the conversion of money to knowledge. Innovation is the conversion of knowledge to money, and they are different processes. And some of that requires the development of new knowledge. Some of it requires the application of existing knowledge into a smart way, and that means you need to know the knowledge that is there. So the first thing is research is always important. It's not the whole answer, but it's an important answer to some of the questions. The other one is that once you have developed an answer, it's about getting it into use in some way or another. And there we are struggling with the size of the organizations that are going to use these things. It's okay to talk to a big multinational with a large competence base internally, because they know probably at least as much as you know as a researcher about the topic you talk about, so they can absorb it and put it to use and make a judgment on it. When you talk on an SME, I mean, most SMEs are characterized by three things. They have no money, they have no time, and they have no absorptive capacity. So therefore, trying to get them to absorb this new knowledge and put it to use requires complementary tools, like the UK Catapult Centre and Norwegian Catapult Centres and so on, that actually helps them to understand through practical application to show them the benefit they can get, and therefore the next project they are willing to work with because the perceived risk is reduced and therefore the return is easier for them. But that is a process where you require almost the old agricultural process with an extension service that goes out and talks to these companies and show them how to do things.
Great, thank you. We've got another question in the chat from Cello Sabi. Which low carbon pathway has received most funding for RDI in Europe and why?
I'm not sure I can answer that one as such. I mean, I do know that there has been a lot of money poured into the hydrogen route for steel or iron. I would assume that is one of the bigger ones, possibly followed by the cement one. But I do not have the numbers, so therefore I would have to take that on notice. If you're interested, you can probably find that out, but I don't have the numbers now, but those are my gut feels.
Okay. Well, we've seemed to have run out of questions in the chat and the Q&A. So there was one other thing I was going to maybe ask about. You mentioned the German withdrawal from nuclear power, and I have a vague recollection that was also related in part to sort of pre-Ukraine, that the Germans were feeling quite secure with Russian gas, and now that's not the case. You haven't mentioned, you mentioned the war in Europe, but what are those sort of broader implications? And am I correct in thinking that that was part of their decision? Yeah. Okay.
Yes, they were. They basically under Merkel's time, they basically put a bet on Russian natural gas, and also about incorporating Russia into the commercial system of Europe, and therefore achieving a more conducive relationship between Russia and Europe. That did not quite work. And as a consequence of both the reliance on natural gas as a policy, as well as a very strong green influence in the government, there was the decision taken to leave nuclear. What we see now is that based on the increasing visibility on the need for both volumes of electricity as well as grid stability, primarily the inertia problem, rotating mass, and events like, both the war in Ukraine, but primarily things like the blackout on the Iberian Peninsula. Now, most countries have changed or are in the process of changing their policy to drive towards nuclear. It may not be the big reactor, maybe SMRs, but you see even countries like Denmark, who has had a long-standing opposition to nuclear, is changing that. So there's a whole set of changes. And of course, from an industrial standpoint, and I apologize for simplifying things brutally, but from a very large reactor, you get electricity, basically full stop. From SMR, you get about 60% process heat and 40% electricity. That means that with the location of an SMR at the right area, you solve two problems in one go. Now, of course, the heat is not going to be up to the level you need in metal smelting, but at least it's going to deal with things like food and chemical industries and other type of activities. So that means that there are the benefits of grid stability, the benefit of reducing the load for heating out of the electricity system and decarbonizing that heating system for normal process industries. The SMRs provide both solutions, which from a decarbonization point is very good. And if you add to that the grid stability challenges and the growth of electricity demand, then you can see why many of these countries are moving that path. So we see that clearly. We see different policy for moving it. The big ones require definite government involvement, primarily through loans. It doesn't cost the taxpayer anything. So what the government does, it borrows money at government rates, lends it on to the infrastructure builder, in this case, at same rates, and therefore it's really no cost to taxpayers. It just that provides a capital advantage to the people who get the order to build these nuclear power stations. And also the learnings from the big reactor that came online in Finland quite recently, the incredibly positive effects that had in other boundary conditions being negative in other countries has also driven a move towards the nuclear policy. And even Germany is now reflecting, at least in the political domain, around how they're going to return into the nuclear domain in some aspect or other.
Thank you. Now we've got another question come in from Louise Vickery, and she says that given that Australia's strength will be producing green iron, and 95% of our iron ore goes to China, Japan and Korea, are you aware of cross-border Australasia type regional collaboration that share the costs, benefits and risks of building a green iron and steel supply chain?
Well, there are some. I mean, BHP works with one of the big Chinese steelmakers around some of the evaluation and test activities around that. So that's just one example. So they are happening there. The challenge here is very much it's the type of steel and iron you're doing wherever you're doing it, and it's the market balance between the supply and demand. So on the one hand, it is likely, and this is my view, so I may be completely wrong, it is likely that there will be some dumping of steel from commodity steel from China into Australia as a consequence of the US market having been closed for them, and they have a huge surplus that they need to get rid of somewhere. And that, of course, is not going to be conducive to investments to drive up costs in steel production. The second one is that, as I mentioned, the chemical industry, going down the route of green steel in the commodity market is almost impossible. So unless you really can drive down your hydrogen and associated costs, that means that the only companies that can carry the cost of the green premium are companies in the steel industry that makes really specialized steel that is very hard to make for the average steel maker. Therefore, they have the ability to load a price premium onto a product that already is more expensive, and the customer has a willingness to pay for that because they can't get the functionality anywhere else. So that was answer to two questions. One is, yes, there are things happening with China. There are two aspects that impact that. One is the China's need to get rid of a lot of their steel that they have. Most of their steel is commodity, and commodity in its own right is very difficult to deal with price premiums. So you need to be in high value added products in order to absorb the price premium or pass it on.
That's great. Thanks, Göran. Well, look, it's been a very interesting discussion. I've certainly enjoyed it. I'm sure all of our participants have as well. I'm going to close us down a few minutes early. I think we've run out of questions, and as I mentioned to you before we started, Göran, I've got a pretty tight window to get to the airport. So I'm going to go and grab myself an Uber and Thanks everybody for attending. Thanks, Göran, for your time and for your contributions to South Australia's sort of economic development over many years now. So it's been great, and I'm sure that will continue. So have a safe trip home, and we'll see you on your next visit.
Thank you.
Thanks, Göran. Thanks, everyone.